All right, sixth graders. So far in our geometry unit, we've talked about area and surface area, which is the amount of two-dimensional space polygons and polyhedra take up. Now we're going to move into 3 dimensions and talk about volume, which is how much 3-dimensional space would fit inside a 3D solid or a polyhedron. So we know length is just measuring one aspect or one attribute of a geometric figure. So like the length of the pencil. That could be measured in inches, centimeters, just units. Okay, linear units. Area, we've talked about, is a two-dimensional attribute where, for example, you would have like a length and a width, or we've talked about base and height, and those are measured in units that are squared. So like square centimeters, square inches, units that are squared. We're going to move into volume today, which has 3 aspects. It's a 3-dimensional attribute of a shape. So you might have length, width, and height. Or we're also going to talk about surface area of the base, which is 2D. And then the height gives it the 3rd dimension. So volume is measured in units that are cubed or cubic units. We want to know how many cubes or cubic units could fit inside of that 3-dimensional figure. So we might measure in cubic centimeters, cubic inches, units that are cubed. What I would like you to do next is on your Google Doc, on the virtual one, this is an active link. So go ahead and pause this video, watch the one that's linked in your virtual Google Doc, and then come back to this video. So after you've watched this video, let's go ahead and talk about the general formula for the volume of a prism. So in the video, you saw how, for example, they were showing you a base layer of cubes that was fitting inside a prism. That base layer is like finding the surface area of the base. And then they started stacking up more layers on top of that base layer. So if you know the surface area of the base, you can multiply it by the height of the prism to figure out how much volume your shape has. So for the general formula, here's how we're going to write it. We're going to say it's the surface area of the base, meaning the base of the prism, times the height of the prism. So the surface area of the base is actually going to depend on what type of prism you're looking at. If you have a rectangular prism, the surface area would just be base times height. So if it's rectangular, the surface area is just the base times the height. If you have a triangular prism, the base of the prism is actually a triangle shape. And to find the area of a triangle, you have to do base times height divided by 2. Okay, so you'd find the surface area of the base first, whether it's rectangular or triangular, and then you would multiply by the height of the prism. So let's look at some examples together. So here's your first example. You have a rectangular prism, and actually on a rectangular prism, any of those faces could be the base. I'm going to say this one is what I'm going to designate as the base. So this is what I'm going to start with. I need the surface area of that base. So think about making that base layer of cubes. So this rectangle is a 4 by 5, right? Because it's the same as this one up here, right? 4 by 5. So it's a 4 by 5. So the surface area of my base is going to be 4 times 5, which is 20. And then we need to multiply that by the height of the prism. So think about stacking that base layer of cubes up by the height of the prism. So to figure out where the height of the prism is, look at your base, and then figure out how far is it to the opposite parallel base. So if you think about going up from the base to that face that's opposite and parallel, that height is going to be 5. So I'm going to take my 20 and multiply it by 5, which is going to give me 100. And we're measuring in centimeters. And since we're finding volume, it's cubic centimeters. So you can use your little exponent of 3 to say cubic centimeters. Okay, so just to recap, this was finding the surface area of the base. And then this part was when we multiplied by the height of the prism. Okay, which gives me my volume. So 100 cubic centimeters could fit inside of that rectangular prism. Go ahead and pause the video here and give this next one a try. This one's also a rectangular prism. So pause the video and give this one a try. All right, now that you had a chance to try this one, let's go ahead and go through it together. So again, since it's a rectangular prism, you can designate any of the faces the base. So to me, it looks like this one is kind of on the bottom of the prism. So that's what I'm going to use as the base. So the surface area of the base, or you can think base layer of the cubes, that first layer would be 6 by 6. Okay, so 6 times 6 gives you 36. And then I need to figure out the height of my prism. So if you think from the base to its opposite parallel face, the other base, you can think about going from the base up. That height is 3. So I'm going to take my 36 times 3, which is 108. And we're measuring in meters. And this is meters cubed since it's volume. Okay, so 108 cubic meters would fit inside of that rectangular prism. All right, let's move on to the triangular prisms. So for triangular prisms, the triangle face is always going to be your base. So I'll highlight it so you can see which one I'm talking about. So I first need to find the surface area of the base. And in this case, it's a triangle. So we need to do the base of the triangle times the height of the triangle and then divide it by 2. So since we're dealing with the triangle, looks like base is 3, height is 4. I'm going to do 3 times 4 and then divide it by 2 because it's a triangle. 3 times 4 gives you 12. And then 12 divided by 2 is 6. Then, just like we did with the rectangular prisms, we need to multiply by the height of the prism. So look at that length between those two triangular bases. That length looks like it's 7. Okay, so from this base all the way to the other one is 7. So I'm going to take my 6, multiply it by 7, and that is 42. And we're measuring in meters, so this is going to be meters cubed. So 42 cubic meters would fit inside that triangular prism. Go ahead and pause the video here and give this other triangular prism a try. All right, now that you've had a chance to try that triangular prism, let's go through it together. So remember, the triangular faces are going to be your bases in a triangular prism. So I'm going to highlight this one on the bottom. That's going to be the base I'm working with. So we need to do, since it's a triangle, base times height divided by 2. And it looks like here's our little right angle. They've marked your height as 1.5 yards. And the base is this length here, which isn't marked, but it's the same as this one up here. So that's going to be 1.5 yards times 5. And then don't forget to divide by 2 because it's a triangle. Let's see, 1.5 times 5 is 7.5. We have to divide that by 2. You get 3.75. So that's the surface area of the base. Then we've got to multiply by the height of the prism. So think about that length that's connecting those two bases. And that length looks like it's same as this one, 4 yards. So I'm going to take my 3.75. Kind of out of room, so I'm going to write it down here. 3.75 times 4 because that's the height of my prism. And that comes out to be 15. And we were measuring in yards, so this is going to be 15 cubic yards or 15 yards cubed.